So let's look at the inclined plane problem and how do we calculate when our object is at rest on the incline and we're asked to calculate or determine the normal force and or determine the force of friction. Well, you're going to be given one of two things. You're either going to be given the mass of the object, and you're going to know that because it's in kilograms, or you're going to be given the weight of the object, which is actually force due to gravity, which would be in newtons. So let's say we got the mass of the object, and the mass of the object's 10 kilograms. And you're asked about the normal force. Well, you know that the normal force is the support force. And the normal force, of course, is always perpendicular to the surface that the object is on. But it's not on a flat surface anymore. So it's not the same magnitude as the weight. So I can't just say, well, it's 10 times 9.81. So what happens is, here is my weight vector, Fg. It's pointing towards the center of the Earth. But now I have to break up this vector into two components. And the reason being is that my object is on an incline. So the other thing I need, of course, is I'm going to need what the angle is of the incline. So let's say we have a 30-degree angle. Okay? So the Fn is going to be the same magnitude as our F parallel, or mg cosine of theta. So it's this equation down here, F perpendicular is m, which is 10 kilograms, g 9.81 meters per second squared, and the cosine of 30 degrees. And you hear a truck? Yes. So, in order to figure out what this value is, I'm going to go to my trusty rusty calculator. Where are you, calculator? And let's figure it out. So make sure your calculator is in degrees. So I'm going to take 30 and I'm going to take the cosine. I'm going to multiply that by 10 and multiply it by 9.81, which is little g. And I get an answer in 2 sig figs of 85 newtons. Okay, so that's the perpendicular force, which is also the normal force. So that was equal to 85 newtons. Now, if I want to know the force of friction, which is holding it there and it's not sliding down, then I need to figure out what's called F parallel, which is the other component of Fg. So, let's do it. F parallel, which in this case is F force of friction, and what is that equal to? Well, my mass, 10 kilograms, my G, 9.81 meters per second squared, and of course, now I need the sine of 30 degrees. Of course, the sine of 30 degrees is 0.5, so 0.5 times 10 is 5, and then it's just going to be 5 times 9.81. Hold on. 5 times 9.81. It's 49 newtons. Okay. So in this problem, my force of friction is equal to my force parallel of the weight, and my normal force is my force perpendicular of the weight. So that's taking this weight vector here, this one, and breaking it up into its two components. Really, if you think about it, it's an x component and a y component. Sometimes the F perpendicular will be referred to as FGY by a teacher, and the F parallel as FGX. Check out this video again and more videos. Good luck. So let me recap here in the end. The object is sitting on the incline. It's not moving. So the F net is equal to 0. Forces come in pairs, so your Fn, which is 85 newtons, is exactly the same as my F perpendicular, or FGY, of 85 newtons. The force of friction and the parallel force, or FGX, is the same magnitude of 49 newtons, right? It's our own weight, or in the case of this object, it is its own weight that would have it sliding down the incline. But since 49 newtons is the FGX, 49 newtons is FF, they cancel out, and the F net is 0. Check out this again and more videos. Good luck.